So hi candidate, very good afternoon. Ankit this side. So let's just share my screen. I was waiting for the host right? So now I have quickly shared my screen as well, and let's just continue with the yesterday topic that we were just particularly covering the ANN introduction part with sort of like breast cancer kind of model building that we were doing. Okay, so I'll just open the same notebook, practical part of ANN, and we were facing some sort of issue. The problem was related to the accuracy was not improving, right? So let's just try with some different iterations, and if we are not still getting the multiple errors, or if you're not improving the accuracy, then we'll try it with the another project, and I'll just simply let you know what exactly the issues are, right? So this is all about the artificial neural network, right? So instead of this min-max scaling, let's just use the standard scaling this time, right? So you know that we have two different set of like the technique of our data pre-processing. The first one is called the MinMax scaling, where it try to normalize the data in a range of 0 to 1, right? So what I'll do, I'll just simply call the standard scaling. Okay. So let me just call this. Okay. Now I'll run all the codes: cancer dataset, X dataset, X dataset, right? Y dataset as well. And let me just uh, split this data set into training and testing part, right? Okay, so instead of min-max scaling, now what I'll do, I'll just use the standard scaling technique, right? So let's just use the standard scaling technique. So the model, the standard scaling is like it will turn out the data in a set of zero mean and one standard deviation. That is called standard deviation, right? Let me just show you standardization in ML. So it's like you are converting your data within a average mean of 0 and one standard deviation of the data, right? So what you will do, you will use this formula to applying the standard deviation. Whatever the new data points, the new data point that you will get with the help of actual data point minus mean value and divided by the standard deviation value, right? Let me just quickly show this, okay? So that you can relate this one, how exactly this normalization and standardization techniques working, okay? Suppose I have this like sales data set, okay? And let's just pick some dummy values. So is equals to rand between. And let me just take a value of rand between like 1 to and 1 to 5,000. Okay. So these are my sales data set. Now I want to quickly make it to the min-max scaling. So if I want to convert this to min-max now, the technique is called the normalization technique. So for that, what you can do, you can take a reference of this formula. Now, what exactly this formula is? The new x value will be calculated by original x minus x minimum and x maximum by x minimum, right? So you can just check this one. New original x is calculated by x minus x minimum, okay? You have to subtract the x minimum. So what is the minimum value of this? It's like minimum of this particular data. And let's just freeze this. And then quickly divide this data by x maximum and x minimum. So the just call the maximum formula. Again, quickly select the range, keep it absolute reference, divide this maximum value and divide this whole numerator with this denominator, and it is like maximum minus minimum. So let's just copy this minimum one, right? Okay. Now once you solve this one, so you will get some sort of min-max new value, right? So instead of, okay, I'm getting some sort of issue. It should be in a range of 0 to 1. So let's just simply close this inside bracket so that the value that you will get is a perfect one. Okay. Now the final value will be in a range of 0 to 1, right? Okay. So you can just simply check this, right? Let me just freeze this value, or you can just take a new reference of the value as well. Okay. So the minimum value you will get is 0. The maximum value you will get 1. And the data set will remain like this. Okay. Now the problem is sometimes interviewers generally ask, will that distribution, will that set of pre-processing change your data distribution? So the answer is no. You can just simply go to select this one. You can select your data set, and let's just call this scatter plot, right? So this is before normalization. This is before normalization. Okay. It's like actual distribution. Let me just write this as actual distribution. And if you just want to show the plot for new data set, you can just again go to this insert, click this one, scatter plot, and just change the color so that you can understand this is like your new data set using the min-max scaling technique. Okay, just look at this. Are we getting any set of like any changes inside the distribution? No, three data here, three data here, one data here, one data here, two data here, two data here, right? Followed by two data as well. So this is like applying min-max technique. Okay, using min-max technique. Okay, now let's just use the same standard scaling technique. So what is standardization? It's like x original minus mean of this divided by the standard deviation. Okay, so first you have to calculate the standard deviation. Okay, so now let's just add a new column, and you will use the standard scaler, and the standard scaler is somewhat like this. You will divide, you will just simply call this value minus mean of this. So how to calculate the mean? Simply call the average. You will not get the mean here. You can call the average. Average of this one. Now let's just subtract this one. Average of this one divided by, close this inside the complete one, divided by the denominator, and the denominator is nothing. It's a standard deviation of the given population or like a sample. So just simply you can call the standard deviation, right? Standard deviation of a population. Okay, so you can just call the select the range, fix the reference, and you will get the data and within one standard deviation. Now let's just quickly turn out this. You can just simply check. This is the standard scaling technique candidates, right? Okay, now just simply copy this, select this one, go to this insert, click on this, and just look at this. Are we getting any like changes in the distribution? I don't think so. The distribution remains same, right? So this is the core crux behind all this formula, right? It will not affect the distribution. It will just try to pre-process the data in a given set of range, right? And we can use this. You can just check, right? Two dots are here, two scatters are here, three are here, some sort of three here, like 1, 2, 3, 4, and 1, 2, 3, 4. So the distribution using this min-max techniques and using this standard scaling technique, right? So what we will do, we will use the standard scaling technique. Okay, so you can use this standard scaling and min-max scaling. Yesterday we were using this min-max scaling. Now we just try to build the model using the standard scaling to just cross verify whether the model is performing well or not. So let's just call this one, call this, same as it is, call this one X-train scale. Now call your model as well. Now just try to run your deep learning model, which is artificial neural network. So you are just calling the sequential dense and everything all about the optimizers and all, right? Now you have to call your data set, and you know that you have to build the model, right? So the model is followed by their ReLU activation function, input sheet, everything will remain same. We can just simply hit and try with the dense layer part. The final activation will be sigmoid activation, right? Now just quickly run this. Let's just check the model.summary, and see, you can just pick the and cross entropy as binary cross entropy, right? The loss is like the output is like binary in nature, na? So you can call the binary cross entropy is also a set of laws that you can refer, right? So ADA grade we can use, Adam optimizer you can use, right? These are the compilation that you can use. So let me just call this to Adam one. Previously we were using this. The learning rate is like some sort of fixed binary cross entropy and like this one. Perfect. Now compile this model and try to run this for the model.fit. We are giving the X-train data set, Y-train data set scale. Okay, let's just keep these epochs to 100. The validation split is there. Okay, batch size. We can control the batch size as well. So let's just first run this, right? Now you can just check, right? So it was like the problem was mainly related to the seed. Now just look at this. We are getting the accuracy of 1, 1, 1, 1, 1. Like at just only 40 and 50 iteration, right? So I don't think there is a requirement of just running this model again and again for the 100 of the iteration. So what you can do, you can just simply reduce the iteration size. You can just reduce the epochs, and let's just quickly make it 40, right? And now what you can do, you can just again fit your model, okay? And you're just getting the accuracy that start with 1 because of the previous history cache, right? So just go to this, create a model again, okay? And just compile the model and just run this model, fit this model, okay? And you'll get the, see, you are getting the accuracy of 100% at the 20 or like 20th iteration, right? So what is this cause candidate? I hope everyone is getting my point, right? We were building this model, okay? We were like using the wrong standard scaling technique. We were using the min-max scaling, and we can use the standard scaling, right? And it could be due to the laws that we are using. We're using the categorical cross entropy. It is recommended, but we have to use, because the output that we are getting is the binary in nature, na? So we have to use the loss as a binary cross entropy, right? Now just you can check this one. We are getting the accuracy of 100%, and not just getting the accuracy. The previous loss is, it was 53%, reduced to 25, reduced to 1%, 8%, 0.001% closely, and now close to 0, -4, like epsilon -4 is like 0.0004. So the loss is closely related to 0, and we are able to achieve the accuracy of 1. So in this way, candidate, you can just build this neural network model. Now, the best part is now, let me just hide the hidden layers, right? Let me just hide this one. Okay. What I'll do, I'll just simply get the data, create a one-liner like 64 of neuron, and finally give it to the one activation function. And now let's just try whether the model is performing well on this or not, right? So that is the main benefit of this one. Yes, we are getting the accuracy still close to like 100%. So this is the best case of this, of like this set of hidden layers, right? Now I think everyone just can like imagine that we can control this dense layer network, and that is the reason we are referring this as a deep learning model, right? Where you can simply pass the multiple dense layers, right? And if you just try to increase this hidden layer, and let's just keep this to 32, and let's just run this again, and now run your model again, and you will again get your model accuracy as 100%. You're getting the 100% or like close to 100%, okay? And you're also minimizing your losses as well. Perfect, candidate. So it's all about the it's all about, you can use the like set of any dense layer. Perfect. In this way, candidate, you can use this model. Now it's time to evaluate your model. So let's just evaluate model performance. So you can just calculate two things, right? You can just simply call your model dot, we have this method which is called evaluate, and this will generally take the same one like x test and the y test. This as x test and y test. Now if you just run this now, you'll get two things. The first thing is called loss, and second thing is called the accuracy. Okay, but just let me know, we are getting the accuracy of 0.30%. Is it so? Let me just run this again. Okay, now the problem is why we are using x test, right? We have to use the x test scale data set now, because we have scaled our data set. That is the reason we are getting the 30% very poor accuracy, right? Now since we are using the scale data set, now we are getting the accuracy as 97%, and this one is like your loss. So you can just unpack this data, unpack this answer into two different things. The first one is called loss, and second one is called the accuracy. Now let me just run this, and you can print this one. The model accuracy is, you can call the f string, and let me just simply call my accuracy multiply by 100, and you can just copy this one and paste this one. The model loss is some sort of loss, and you can just multiply it with 100, right? So we are getting the 97% of accuracy, and the model loss is 8%. It's good, right? We are not achieving the 100% accuracy. Why? Because we have eliminated some sort of dense network, right? Right now, we are just using the 64 neuron, 32 neuron, and finally 1 neuron. The more you can increase the hidden layer, the more dense network it will be, and it can particularly close to overfitting as well. So you have to be very make sure that you will not train your model so well so that it could end with the like overfitting. And you know that how to tackle with the overfitting as well, but it's important to keep the dense network whatever the required, right? Now you know that since you have developed your model now, so you can just simply predict the values, right? So let's just call any sample data from the X data set that we have. So sample data is equals to, let's just call the X train data or X test data, right? X test data, go to this X test data. Why I'm not getting this one? X test data, we can simply call one sample. And if you just call this sample now, so you can just pass this to model, model dot predict, and you have to give this sample data. And you know that this will try to predict both 0 and 1 possible value. Okay, why we are not getting the answer? Okay, the numpty nd object has no attribute sample, no issue. So what you can do, you can just simply go to this PD, you can make it to data frame. Well, it is not required since we just want sample. Na, that is the reason we are converting this to data frame. Why the problem is PD is not defined, why is so? Our mistake, you have to import the all the required module at this top, right? So import PD as PD, and we are getting the prediction values as this one. And you know that this is like close to 0 or 1 as well. So what you can do, you can just simply make this rebel. Rebel is like you are flattening your array, and you can just call this data. Okay, now just simply do one thing. Let's just store this data inside the answer, right? And because this is the kind of binary classification, so you have to run the very basic if else. So you can directly pass this inside like the print one. So if the answer value is greater than 0.5, so the model will say 1, and 1 is like the cancerous one. Okay, and otherwise it will say 0. Okay, so you are running this. Let's just run this one, and it is like 0. So the 0 is like the given data is not the cancerous one. Let's just run this again. Now this time it is the cancerous one. Now just run this again. This time this is the cancerous one, right? So you are particularly predicting this. If you want, like instead of this 0 and 1, so you can just type this one. Okay, cancer, no cancer. Okay, cancer and no cancer. Okay, so in this way, candidate, you can get this cancer and no cancer. Now, what about the probability? The best thing is that now, if you just run this answer, so this answer will give you the probability itself. Whatever the 0 point values that you are getting, if it is close to 1 now, and the floating value itself is a probability. So you don't need to calculate the probability here. You will get the probability, right? And you can just simply check this as a probability as like just simply call this answer and multiply this with 100. And the probability of cancerous is like 98.89%. You can keep it round to. Okay. So candidate, the probability of no cancer is 0. Okay. Okay. Now we have to just simply check because the value was close to 0 now. So we have to simply check that one, right? Why we are getting the values as 0, right? So now just simply call this one model.sample. This one, we are getting the values like this 100%. So you can just call the probabilities as well, right? So candidate, in this way, you can create your model. Right now, you have some sort of homework. What you have to do, whatever the model that we have performed, okay, like the breast cancer one, okay. So you just take this data set and try to compare this model building with ML versus DL. And inside ML, you can use the logistic regression, you can use decision tree, you can use random forest, you can use KNN, you can use SVC, okay, and you can use multinomial naive Bayes as well, right? And then compare this with ANN. ANN is like artificial neural network, right? And the best possibility that you will get is the logistic regression close to the answer of ANN. Why? Because inside the ANN itself, we are using this sigmoid function as an activation function. And we know that the logistic regression is completely based upon the sigmoid activation function. So candidate, in this way, we have sorted our project, and this is the main like ANN kind of implementation. Now let's just start with the another one. Okay, so we have some sort of data set, because today we have like 2 hours of class, so we'll try to build multi-model things, right? Now let's just start with the different project. And now the project is some sort of let me just share this notebook with all of you so that you can practice same. Okay, so is there any doubts or question, candidates, do you have? You can just let me know. So I am sharing my like collab notebook with all of you, and I hope you all of you are already clear with this one concept, which is like the MinMax scaling technique and the standard scaling technique, right? Okay. So now let me just close this one. Okay. We have a problem, and the problem is that the companies are particularly being an HR, you have to check whether your employees are leaving your organization or not, right? So you have a one project, and that project is called the attrition or churn rate calculation. Okay, attrition and churn rate look same, but it is different. If the employee is leaving your organization, that is called attrition rate. Attrition and churn rate prediction using ANN. Then we'll start the CNN, and then we'll create the project for the CNN as well, right? Okay, so once the, what is attrition? Attrition is like employee leaving your organization. Okay, employee leaving your company, and the rate of employee leaving your company is called the attrition rate. And what is churn rate? Churn rate is like the customers leaving your services. Okay, it's called the your services. Okay, so the metrics look same because the calculation that we are using is the same as well, right? Okay, so first of all, we have to get the data as well. Okay, so now let's just quickly import all the modules. So step one is to load important modules. We have already imported some sort of module because this is another project, so we'll try to import the same as well, right? Okay, now let's just quickly call the different modules. So the first that we have already imported, let me just copy and paste this one. All this one, import TensorFlow, so and so, right? Import pandas as well, numpy as well. Let me just write this, import pandas as PD, import numpy as np. Have to call the multiple as matplotlib.pyplot. Import cbone as SNS. Okay, and you have already imported the modules now. So let's just keep it as import OS and import warnings, and let's just keep the warnings dot filter warnings as off, like ignore. Perfect, and keep this as done. If we want to import any future module, then we can simply call this one, right? Okay. Now what we want, candidate, we want the one data set that is called customer churn data. Okay, so just simply go to this and write this one, customer churn data CSV Kaggle. You'll get the same as it is, right? Just simply click on this. You'll get different data set. Let me just first check this one. You can just copy this one, import Kaggle have. Simply go to here, run this one. You have that OS module. With the help of that OS module, you can simply run this one. Okay, so OS dot list dir, just simply call your path. You'll get the two data set, the training and the testing. Okay, now let's just try to call another one because we are getting the data divided into two partner. So free customer churn data set, let's just check this one. Yeah, the data set itself in a form of like training and testing one. See, I don't have any problem to using any of this, right? But the problem is now the data that is already divided into training and testing part. So we want to perform the training and testing part in sort of like the training and testing is split, right? So we can use this one, okay? So customer churn data CSV. So let's just check this one. We have some sort of different options. Now let's just check with the GitHub one. Then I'll get the same as it is, right? Customer churn prediction. Okay. So IBM Telco, let me just check this one. Yeah, this is the some sort of data set. Okay, customer ID, gender, senior citizen, and okay, where's the final value? Okay, now let me, oh, okay. What you can do, you can just, either you can copy this one, or let me just copy this URL. Okay, and simply ignore this one also, and paste your URL here. This is the URL, right? And if you want to perform this one, this is the IBM dataset, right? So we are using the IBM dataset URL. This is the URL. Now I want to directly use this dataset. So you can just simply, okay, let me just copy and paste this inside the meeting as well so that you can take a refer, right? It's like telco raw GitHub dataset, and it's the complete CSV file, right? Now let's just try to read this file directly. ed.read_CSV. If I just simply hit the URL, it will directly try to load the dataset because the dataset itself ends with the .csv extension, right? Let's just simply store this inside df. Okay, I'll do some basic EDA. df.shape, perfect. df.columns. So we are getting the like df.shape is like 7043 data, 21 set of columns. These are the df.columns. You can just simply check, right? If you want to call some data set, it's like head data set, customer ID, gender, senior citizen, partner, dependents, tenure, phone service, multiple lines, internet services, online security, dot means you have some sort of 21 columns now. Although if you want to keep this, like if you want to check all the columns, so you can just use this one, pd dot set options, and you will get this option as display max columns. And let me just run this as display max columns as 30. Let me just run this. Will that work? Okay, now I need to take a help from the documentation. pd.set option, just simply over this pd.set option, you will get the option here. Just go to the documentation part and you'll get how to, yeah, this is the thing, display dot maximum directory, display dot where's the max column, display dot max column. You'll get the max column here, right? Yes, this one, display dot max columns. Okay, just write this like this, display dot max columns, and you can increase the number of column just like this one. Okay, let me just pass this one, display dot max like this, and let's keep this like, okay, we want to display all the 21 columns now, so you can just simply say this as df dot shape of 1. It's like the column length, right? So let's just run this, and let's just run this. Now you can get all the columns, right? Internet service, online security, online backup, device protection, tech support, streaming, and so on. And finally, whether the customer has churned or not, right? So it's not like the attrition. It's like the set of, because this is not the employee ID. This is the customer ID. Na? So the problem is not related to the attrition one. Now the problem has become the churn rate prediction. Okay, so you have this data set candidate. So it's very important to understand the type of data types that we have inside all this. So df dot let's just run this as data types. It will give you the data types. Okay, we are getting everything as like the object data type, most of object data set, right? So now let's just treat all these value, right? So in this way, you can just simply understand how to do the feature engineering part and the pre-processing part, because right now we are getting the multiple data set. Okay, so now let's just call this sample and just try to understand which column can be dropped. I don't think if we want to predict the customer churn rate, there is a requirement of customer ID. So you can just simply drop this customer ID, just copy this customer ID, pass inside this codes. You know that you have to give the access, and you'll get the new data frame. And you can simply store this data frame inside a new one, right? Instead of in placing this as a true, you can simply store this inside a like new one. Okay. Now let's just check the missing values first. Okay, missing values also. So you can just simply call, because the data frame converted into df1, so you can just call the is na, and inside this is na you can call the mean method. It will directly give you the mean value, right? So we are getting 0 0 everywhere. It means there is no such missing data inside this, right? Now we have to treat all this numerical one. Okay, so let's just call all the textual column and the numerical column. So how to call this one? You can just simply call this df1 dot select data types, and inside this select data type you can write this object, and these are the columns that are object in nature. It's like the textual data. So what you can do, you can just simply check, and if you want to run the for loop as well, you can run the for loop, right? So let me just quickly call one column, right? df.gender, and I just want to check the unique value, right? So how to check the unique value? You can call this unique method, and it just say, okay, we have male and female inside this gender column, right? Now, what about the rest one, like the partner one and the departments one? If you do this, so you have to like keep this again and again. So it's not the partner, it's like the partner, PRT partner. Okay. So instead of writing this manually in a class, I'll just simply try to run a for loop over this one. Okay. So let's just call this one for I in df1 dot, that select data types. If I just simply pass the select data type as object, it will give me those data frame that they are object in nature. Okay. Now I'll just simply call my x is my column name, right? So I'll just simply hit the f string, and I is like my column name, and you can just simply refer this column name has like this unique value. So you can just call the df1, call this x one column, I column, and what you want to just print all the unique values, so you can run this one. And now let's just run the another extra line to keep it separate, right? So in this way you can get all the values. So inside gender column, you can just write this also as well. So column gender is equals to, we have two different values. Okay, and column partner we have yes or no, column dependents we have no, yeah, yes, phone service no, yes, multiple lines no, phone service no, yes, internet DSL fabric option no, yes, no, multiple things that we have like in this objective data, right? The payment method, electronic check, mail check, bank transfer, total charges. Okay, now this is some sort of like similar to the floating data, but why the data is stored inside like the quotes one? We have to treat this one, right? So these are the things that we are getting, right? So let's just treat this all values, right, one by one. So these are the values that we are getting. Okay, now we have to replace everything in just one go, so that we can replace all the values with the numerical one, right? Okay, now just look at this candidate. Inside this phone service, where is the phone service? This one. You can just check inside this multiple lines. We are getting no phone service and the no as well. Can I just say no phone service and no, or both are same? So why we are referring two different like attribute for the same? Okay, same as it is in the online security. We are calling no and no internet service as well. Same here, no internet service. Same here, no internet service. Why we are referring multiple attributes, right? If we have simply replaced this no internet service to this no one, right? Okay, perfect. And just look at this. Here, every yes and no, can we just simply replace this to like no to 0 and yes to 1, right? So if we can treat all these value now, so we can simply like convert the objective data into the numerical one. So let's just run this. df1 dot, you will get this method which is called the replace, and you have to pass the dictionary. Now, inside the dictionary, what you want, candidate, you just want, let's just copy this no phone service. And what I want, this is my key, and I want to make it as no. Perfect. Same what I'll do at this no internet service. Okay. Again, I'll pass this as key, and let's just make this again as no. Why I'm doing this? So that I can simply convert my each no and yes to 0 and 1. Okay. Now let me just run this. If you just run this now, candidate, so your each value will be converted to no and yes. Okay. Now what I'll do, again do one more thing. Just again call the replace method. And now inside this replace, I'll just simply treat each no to 0 and each yes to 1. Okay. So each no to 0 and each yes to 1. Now, in this way, we will simply convert our each no, yes to some sort of the 0 and 1s. In this way, candidate, we have converted this data into the sort of numerical one. Now, let's just store this data frame inside DF2. This is like a set of pipeline, right? So we have created this pipeline and we are getting the data set like this. Okay. Now, let's just copy this loop. And we just want, okay, how many data types we have converted, right? So let's just simply call this over this df2. Okay. Now call this df2 instead of df1 and let's just run this. Okay. So we have converted all the columns, but right now we are still pending with the female and male. Okay. All these are like the numeric. We have to sort this problem for the internet security services as well. Then followed by the contract, the payment method, and some sort of the total charges. Now we have some limited data. We can simply like convert this to the numerical one. Okay. So now let's just understand the internet services. Inside this internet services, you have two different options. The first one is called the DSL. Second one is called the fiber optic. Okay. And second one is called the zero, right? So these are like you have three different data set. Okay. Now what you can do, you can simply convert this into the numerical one, right? We don't want to convert this using the 0, 1, and 2. Although you can do this, but if we can use this 0, 1, and 2, so this will be like fall inside a trap of sparse matrix where the model will try to understand, okay, 0 means the lower value, 1 means the higher value. It can form some sort of relation, right? This could hamper our model. So what I'll do, I'll just convert this to like the textual one, and then we will use the pd.getDummies. Okay. Once you get the pd.getDummies, then you can probably convert your data into the like the numerical one, and then you can particularly treat the values, right? Okay. So we will keep this for the getDummies one. Okay. Now what about the contract part? We have this contract part. We have to deal this contract part. Okay. And the contract part is like month to month, 1 year, and the 2 year. These are like the set of contract. Okay. We can convert the female and male to 0 and 1, no issue, right? Okay. So we can just, okay. So where is the contract part? The contract is like, okay, let's just do one thing. Na? We have this contract partner. So can we just use this contract part for like pd.getDummies? If we can use this contract part as well. So this will convert our data into the 0, 1, and 2 as well, right? And that will be the good one, right? So let's just try to repeat the same step with the like the overall data that we have, right? So let's just try to do this. Okay. First, I'll just simply convert my data from male, female to this one. Okay. Let's just do this. Okay, and I'm some sort of getting the issue here, right? Why we are getting the floating value, like the textual value, if we have the floating value, right? Okay, we have to deal this one, right? Okay, so let's just first change your data set from numerical, like for the female and male that you are getting. Okay, so I'll just simply call my df2. Where is my df2? I think this is my df2, right? Yes, I'll just simply call my df2. I'll call this gender, and the gender that we are getting is male and female. Okay, you can just simply call and replace what you want. You can just simply say, let's just replace the female to 0 and male to 1. Okay, perfect. If you just run this, here you are getting the perfect value, right? Okay, now what you want. So if you don't want to replace this for like the gender column only, although you can do this, we can simply replace this for the directly df2 as well, right? The df2 directly replace the data set. Okay, we don't need to assign like in the same data frame. Okay, now let's just store this data frame inside the df3. Now inside this df3, let's just check. We are still pending with the internet services and the contract, like 1 year, 2 year, and so on, right? Okay, so let's just call this the df5, and let's make it as a contract pd.getDummies. Yes, we can handle it for pd.getDummies. Okay, so let's just do one thing. Inside this internet service now, okay, just call this column df3 and call this column, right, where the internet services. Okay, inside the internet services, you have three different data set: UNI, QUE, and it is like DSL, fiber optic, and zero. So let's just do one thing. Let's just convert this. We can replace this the zero as no. Why we are doing this? And let's just reassign the value to the internet services as well, right? Why we are doing this, candidate? Because we want to convert this data set not into 0, 1, 2, 3, right? We want to convert this data set with the help of pd.getDummies, right? That is the reason we are performing this. And if we are good to go with the performing this one, na, so we can simply convert this data set into like the textual from the textual one to the numerical one, right? So that is the reason. So we have converted the male and female. We have converted the internet services into the from 0 to no, and we will perform the pd.getDummies, right? Now we are still pending with this payment method and month 1 year and month 2 year, right? We have this column still pending: payment method, month 1 year and month 2 year, right? So let's just do one thing. Let's just payment method. Okay, payment method, we have the different types of payment method is like okay, electronic, check, mail, bank transfer. These are perfect. Okay, we cannot simply convert this to 0, 1 numerically directly. And month 1 and month 2 year, perfect. And we have this one. Okay, so now let's just do one thing. Let's just copy this one, and I'll call my df3. Okay, I'll call my df3, and I'll just check the rest column that is still pending. So we are pending with the internet services, the contract, the payment method, and then followed by the total charges. So what I'll do, I'll just simply use the pd.getDummies to convert this data set directly into the dummy part, right? So let's just directly call the pd.getDummies of the overall data that we are performing, right? So let's just call this one the different column that we want to perform. So it's like pd.getDummies, and we have one column. The one column is called the internet services. Okay, so which column we want to perform? We want to perform this over df3. Okay, you have to write this one: columns is equals to inside list. The first column that we want to convert inside is called internet services. I hope everyone is aware with this pd.getDummies, where we can convert the textual data into the numerical one using the one hot encoding technique, right? The second is called the contract one. Let's just pass this contract. This is my second column. And the third column is like the payment method. Let's just call this as payment method. Okay. Now, if you just run this, so you have to get the data type as integer. So you can just simply select the data type as integer. And once, if you're using this pd.getDummies, you will get an additional column that is called dummy variable trap. So you will just try to remove that column. So you can just simply call this argument drop first is equals to true. It will remove the first column, right? Whatever the like raising the dummy variable trap issue, right? So once you run this, you'll get a new data set, right? And mostly value will be converted into the numerical one. And let's just store this data set inside the df4. Okay, now let's just simply copy this code, and I'll just try to simply run the for loop over the df4 column, because I have converted almost all the columns. Now just look at this. Gender is like 0, 1, 0, 1, 10 years, something like this. All sorted. Fabric 0, 1, 0, 1. Car automatic 0, 1. Okay. Now we're still pending with this value. This is called the total charges. Now, what is the problem with the total charges? The total charges is like why we are getting this set of values. Is there any like categorical data or like object data inside this total charges. That is the reason we are getting this. So we need to check about this, what exactly this total charges is. Okay, so let's just do one thing. Call this total charges df4, call this total charges and call a unique value. Okay, unique value unique. Okay, now what you can do, you can just simply run a for loop, right? For I and I'll just try to simply typecast my data for try my each I as a float data. Okay, I'll just try my each data as a float data, and whatever the except case that I'll get where the try is not possible, so I'll just try to print that I, what exactly the I is. Okay, I'm not getting the issue. So I think every I is like the float I. So let me just check, instead of floating this na, let's just simply directly convert this to the yeah, integer one. We can convert this. Let's just check the data type of this one first, right? So we have this method that is called I dot is instance. Is instance is like whether it is digit or like is alpha num or is some sort of any sort of the like the things. Okay, so let's just do one thing. You can just simply say, instead of try, if my I dot is, if my I is like any digit value, I is like my the values na, so I is like if I is any digit. Okay, if I is any digit, I is like your column. Okay, if I is any digit, so you will just simply pass. And if I is not digit, you will print that I, what exactly the problem is, right? So if I is dot digit, we are getting all the values, right? Print I, print I. These are the digits, right? Okay, we want to check like why we are not getting the values, right? Okay, so let's just do one thing. Instead of this one, let's just try this one. If dot in I, so we will just ignore this one and we'll print the rest one, right? So these are like my the rest values. Okay, now inside this rest value, so what exactly the, like, is there any sort of values that we are getting is not the integer one or like not the float one? That is the reason we are not, yeah, this one, right? This is the problem. See, here is the data, right? We are not getting the data here. Okay, so it is due to the blank string, right? That is the reason we are not getting this data. Okay, so you can just simply check dot is, and you have this method which is called is numeric, right? If it is numeric, it is like true, 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 but somewhere it should be false as well, right? Somewhere it should be false as well. So let's just check where is the false. It should be false, where we are getting the blank space, right? Now there is the false, but yeah, here is the false, right? That one is not the true value. So what you can do, you can just simply check, instead of all this code, you can just simply call this one, uh, copy this, cut all the code, and just simply check if I is numeric, then you can just skip the I, and if it is not the numeric one, you have to print that one, right? Okay, see all these, we are getting all this one, right? Okay, so let's just do one thing. I, two things. The first one is dot should be in I, and I should be numeric as well, right? Now let's just try this one. Okay, we are getting the else values. Run this or operator. Okay, now we are getting the one value, right? Okay, that one value is called the blank value, I think. Yes, this is the blank value we are getting. Now let's just check where is the blank value this is. Okay, so you can call this the index method, and this index method will give you that enumerate, and with the help of that enumerate you can get the index like where this problem is, right? So this problem is at 484 index. Okay, now let's just go to this df4 of ilog and go to this 484 rows and of column, particular all the columns. So once you run this now, you will get the problem in the total charges. Where is the total charges? Where is the total charges column? Yes, the total charges column is here, right? But we are getting the value, right? So where it is, it's like 484. Let's just see, we are getting the index is like at 4. Okay, so it is the, like, you just simply eliminate this numeric And okay, we are not getting the multiple values. Okay, see, the problem is we are getting the blank string at multiple locations, right? These are the locations where we are getting the multiple values. So let's just do one thing. Let's just quickly store this problem, or like wrong values index. See, these are the data manipulation that you have to perform, right? And instead of printing this now, what I'll do, I'll just simply call my wrong values index, and I'll append the index here, right? I'll append the index here, and I'll just try to call the wrong index here directly, and it will give me the complete data frame of that particular column. Like the problem was, yeah, total charges, and here you can check candidate. At all these column, we are getting the blank values, and that is the issue, right? So in this way, we have just checked that yes, this is true. Now what we can do, we can just simply run some sort of operation where we can eliminate this problem, right? So let's just do one thing. Go to df4, call your total charges column, and you can apply some lambda method, right? So call your lambda method. Lambda will try to call each row, and you can just check if this row is exactly to the blank string, so you will fill out this with 0, or otherwise you will keep this as the float value of that row. Okay, so you can just run this. Now let me just run this one. Yes, you are getting the value, right? We are getting the value as the float value. Now just check this one. Okay, we are getting the float value. Okay, so what you can do, you can just quickly copy this, and you can just reassign the value to this data frame series, right? Now let's just check the data types of each df4. So you can just simply call this one and df4.dtypes, and now just look at this class. We are getting everything as like integer, 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 float, integer, float, integer, and the final value that we are getting is the integer. I hope everyone is like understanding these are the problem that we need to face. Candidate, is there any issue or like doubts, class? I hope everyone is understanding that. So in this way, we have to like particularly tackle the problem. Now let's just to understand, we because we are getting the multiple values now, so we have to like feature scale our data. Okay, so let's just quickly check the rest EDA part. So let's just do the some describe or like the statistical part. You can just call the roundness round of 2. Okay, now if you want to do some EDA as well, you can perform the EDA. So I'll just try to keep the EDA side for your side, candidate. You can call the cbond, matplotlib, so and so on. Now let's just check the sns.count plot, and inside the count plot you can just call your data frame, and you can just simply check the number of like the overall data, male and female, that you have, right? So you are getting the values as some sort of like this. Okay, if you want to show the values as well, so the data is not imbalanced when it comes to like gender, right? So you can just try and check with the group one as well, like which one is churning most, whether it is like the male candidates, or like the male customer, or like the female customer. So you can just try and perform some sort of multiple sort of like analysis you can do. Okay, so let's just try with this one. Okay, because we have to complete this project now, and the duration of today class is of 2 hours, right? So we have already completed with the 1 hour. So now let's just try to group this data and to understand how different sort of visualization and the EDA part we can simply perform. Okay, so just simply go to this df4. You can do some group by approach. Now what you want, based on gender, let me just call the based on gender, I want to check my churn rate. Okay, I want to check my churn rate. If you just run this, you'll get the overall of this like panda series. Now what you can do, you can just simply call this one. Okay, in this particular, I just want to plot my bar, right? And it should be for the male only. So let's just do one thing. Let's just simply call this data frame 4, and inside this data frame 4, let's just first check the churn rate for the male one. And you have to, you know that you have to call this series. It's like the masking technique. And inside this masking, you will call the df4. Df4, we are not, okay. So it's not like the male one. The male one, I think, let me just check. The male one is completely changed with the 1, I think. Okay. You cannot just directly bet, just simply check where is the, we have changed this now. Yes, female is 0 and the male is 1, right? So let's just, instead of 0, na, you have to call this one. So these are the male data set that you are getting. Okay, now what you want, you can just call your churn column, and inside this churn column you can create some graph with the help of value counts, and you can directly plot the graph. And let me just simply write the bar graph here. So this is the churn for the male customers. And now let's just copy this. This is the churn for the female customers. Okay, if you want to combine both, you can combine both as well, right? For the male customer and for the female customers. Okay, and if you don't want to show the bar graph, so you can just simply keep it as for the value count as well, right? You can just keep it like this. So at the female customers level, the 0 is like 2,625 customers not leave the services, and 930 already leave the services, right? So it's like you're just checking the data set based on the gender, right? And let's just copy this one and check this for the male as well. The male is like 939 customer already leave the services, and 2549 not leave the services. Okay, so you can just simply check the different sort of analysis and the visualization, right? So I'll just keep this task for your side candidate. You can just do some multiple EDAs, you know that, right? This is a part of a data analyst or for the ML engineers as well, right? But what we want to create a model now. So let's just simply call my standard scaling technique or like the MinMax scaling technique. Okay, so let's just try to keep this data in set of one pre-processing or like in a set of normalizing technique. And you know that if you want to normalize your data set, you have to call from sklearn dot pre-processing, and inside this pre-processing you will get the MinMax scaling, or you can use the standard scaling as well. Okay, so let's just call both. If we are getting problem related to the MinMax now, so then we can use the standard scaling, right? So let's just create this variable, call this, initialize this MinMaxScaler object, right? And you can just simply give your data to the whatever the like column that you want to min and max, right? So let's just simply check. You have this code, right? Where is the code? This one. Okay, inside this one, candidate, just simply look at this. You have the monthly charges, okay, that you want to min max. You have the total charges, okay, and you have where's the okay, you have the 10 years as well, because the rest value are already in sort of 0 and 1, so you cannot particularly use the min-max for that one, right? So we are just applying the limited min-max technique for the selected columns, because the rest column are already in form of either 0 or 1. Okay, so now let's just select that column. So just simply call the df4, and you know that the first column is like the tenure, so just simply call the tenure. Okay, the second column is like the monthly charges. So I'll do one thing, because I need to give the proper name. So let me just call the df4.columns, and let me just copy the monthly charges from here, right? This is the second column. Okay, and the third column is like the total charges. Where is the total charges? Total charges, yes, this one. You have to keep this data in a min-max scale. Now, if you want to do this, so you have to particularly keep this as like a data frame. Now, this is the data frame. Now, what you want to transform this. So let's just simply use this min-max technique. Inside this min-max technique, you have this method which is called fit and transform. And what you want to transform this data set only. So you can just simply copy and paste this data set here, right? And if you just run this, you have successfully transformed your data. Now you can simply run your df.describe, df4.describe and .round2, and now you can just check your all data is like in a form of 0 to 1. Okay, where to check this? The minimum value will be 0. Where is the minimum value? The minimum value will be 0. You can just check all minimum values is 0, and the maximum value will be 1. So in this way, candidate, we have successfully converted this data into a sort of like 0 to 1 technique, or like min-max scaling technique. Now what I want to quickly convert my data set into training and testing part. So let's just simply call my from sklearn. Okay, see, you can perform the EDA part, candidate, from your side, right? So from sklearn dot model selection, let's just call the train test split. Okay, now let's just divide our data set into two parts. You know that df4, the last column is like df4, the last column is like your the Y column. So you can just simply drop this column. This churn is not the X column. You can just simply drop this column with as one, and you can just simply check the sample of this. This is the X data set. Now let's just create the Y data set as well. And the Y is like the churn value, and the churn value is like in sort of 0 and 1, right? We have to predict that churn value with the help of machine learning or like the deep learning as well, right? Okay. So now let's just quickly go to the previous notebook and where we have converted the data set into the training and testing part. So let's just call the training and testing part. Yes, this one. I'll just simply copy this one. I'll just move down and paste it here. Okay, so in this way, we have successfully converted our data into a training and testing part. Let's just simply check the training sizes. Okay, 80%, the random state is something this. Okay, now let's just run this. If you want to check the size, you can do this, right? Now let's just try to build the ANN model, okay? Because we have converted this data, so now you can build ANN model, okay? And we know that ANN model is also FNN. FNN is like the feed forward neural network. Okay, so can it in this way we will complete our project like to predict the attrition rate or like the churn rate of the given data set, right? Now, before directly proceeding this, let's just check, do we have all data type in a numerical now? If you don't check this and if you'll get any sort of error, so you have to handle that, right? We are getting all data type in sort of like the numerical value. Now you know that you have to follow, either you can copy and paste, but I'll recommend to create a model from scratch as well. Now let me just again give you the reference so that you can understand it well. ANN in depth, just go to this. You know that the first one is called the input layer, the second one is like the output, the hidden layer, and the third one is like the output layer, right? So let's just copy this one. You can just take a reference of this. Perfect. Now with the help of this one, you have to create a model. Okay, just simply go to this, add the text here, simply paste your image here. Now just try to build the model with the same set of reference, right? The first one is input layer, second one is hidden layer, third one hidden layer. You can control the n number of hidden layer as you want, and the fourth one is output layer. Now you know that you can all do this with the help of model sequential method. Inside this, you have to pass a list. You have to call the dense neural network. You will decide the minimum neuron at the starting. Let's just keep this 20, then followed by the input shape, right? And the input shape is somewhat decided by the features of that the data set that you have. So it is something like x. You can just call the x dot sample dot shape. Okay, x dot sample dot shape. This is the input shape that you have to give. Okay, so the sample is not the like one rows that you have to give. You have to give the 23 features now. So just simply pass this one as like as x, because we have converted data into the training and testing part. So let's just call this x train dot shape, and you have to give the features part. So this is the feature part, and it should be in a tuple format. So either you can do one thing, you can just simply call this data as well. Okay, we are not getting the like the values as. Okay, so let's just do one thing. Just simply call this one. Perfect. And we have to call one values, right? So okay, x train, and let's just call any of the value. It's like 2142, not 21, or dot ilog. Let's just call ilog will not work right now. Okay, so let's just call 2142 directly right now. Well, it is not recommended to use the key like this, okay? Because the developer can be confused why we are using this, right? And now let's just check the shape. We just want to just get the shape as well. We are not getting the value. Okay, let's just ignore this time and keep this as xtrain dot shape. Spelling of the shape is not good. SHAPE. And you can call the feature. See, we just want the feature, right? So we can, instead of doing this multiple times, let's just simply paste it here. You have to use this one, and you have to give this inside a form of tuple, right? So let's just pass this and create a tuple like this. Okay, now you know that you have to give the activation function. We by default we generally give the activation function. This is the first hidden layer. Okay, now you can just apply the comma, And now let's just create the another hidden layer. If you want to increase the hidden layer, so you can just use the dense. Now let's just make it 10, okay? And you can just use again the activation function. Activation function, let's just keep this as ReLU. And let's just, because we want to predict the churn rate, right? So the finally value should be like whether the customer will likely to be churn or not, right? So you can just use the output function as a one neuron and followed by the activation function as a sigmoid activation function, right? Because the sigmoid is helpful when you are getting the one output value at one time. It's like 0 or 1 when you have the binary classification, right? So you will generally use this model like this. Okay, now you can simply check your summary, model.summary. These are the by default parameters that you are getting. The parameters are like nothing. The combination of multiple weights and biases is called the parameters. So the total trainable parameters we are calling is like 701. Now you know that the second part is to compile the model. So the model compilation is like we have to decide the loss, we have to select the optimizer. So you can just simply write this optimizer as Adam as well, like this one, okay? Either you can call this one as well, or you can just also write this one as well, Adam. This is the method that you can also use, right? Just select the matrices. Inside the matrices, you know that you have to give the accuracy. Then you have to identify the loss, which loss you want to calculate. You know that it is the binary in nature. So let's just write this as a binary cross entropy. CROSSENTROPY, binary cross entropy, right? So let's just compile this model. Now we have successfully compiled this model, and the last part is to fit that model, and then we can evaluate the model as well, right? So let's just try to fit that model, model.fit. You have to give the X train data, then followed by the Y train data. You can decide the number of epochs. Let's just first keep it as 20. Why we want to keep it less? So that we can understand whether the model is improving their accuracy or not. So it's not mandatory to just randomly give the epochs, right? Let's just keep the verbose as 1. If you want to do the validation split, so you can do this as well. Validation split is equals to 20% of the validation split. And if the data set is very huge, so you can call the batch size as well, right? So let's just try to run it for the 20th iteration, right? Okay. The spelling is mistake, ACCURACY, accuracy. Now let's just compile and fit this model again. My mistake, candidate, ACCURACY. Okay, you have to just compile this one and just fit this model. Yes. Are we getting the accuracy on like increasing side? Yes, yes. The loss is like decreasing and we are getting the accuracy improving very much, right? Okay, now just look at this. At just 20th epochs only, we are getting the accuracy of 80%. Now what you can do, you can just again create your model, do some model summary, model compile, and now let's just keep this as 100. Okay, now it will take some time. Okay, and it will try to improve the accuracy. At 7th and 8th iteration, we are getting the model as like close to 80%. It's adjusting the weights, it's back propagating the model, it's training the model. Okay, it's finding the weights, adjusting the weights, do some optimization techniques, and finally we will get the data here, right? If you want to visualize this one with their history, so we can do the same as well, right? So now let me just wait for this. Okay, the accuracy is like, I think somewhere stuck between 82, 83, 84, some sort of like this. Okay, just wait. Okay, we will improve the model if it is not working, right? So the finally that we are getting is close to the, I think 80%. Now, let's just try this. Okay, so the finally accuracy is like 82%. Now just go to the model. Just increase one hidden layer. Okay, and just try to do some weights adjustment. Let's just increase the neurons from 20 to 40 to 10 and then followed by 1. The trainable parameters will be like 1741. We are using the Adam optimizer. Let's just, instead of like this, let's just write this one, Adam optimizer. And the learning rate is some sort of like 0.001. And now let's just run this again. And let's just increase the epochs to 200. Okay, and now let's just wait. Okay, I'll check whether the model will perform or not, right? Okay, so we are getting the some sort of 80% of accuracy. Okay, just wait. Okay, it's not always to improve the accuracy. We have to check whether the a loss is decreasing or not. During the first iteration, the loss was some sort of 65%. Like, and we have to check the loss should be like on a decent way. It should be decreased. Yes, we are somewhat increasing the accuracy at the 50th iteration, 82 and 84. So let's just wait for the 200 epochs to run. And that is the reason now, when you are training your model, it requires lots of consumption of GPUs, because you have to check your model, you have to retrain your model, you have to validate the model again. Then it consumes multiple resources, and that is the reason it costs you so much, right? Let's just wait, and if we get the model improved, then we'll try to particularly use that model, and then we'll predict the value based on that, right? I hope everyone is getting my point, candidate. Is there any doubts or like any issue? Class, Vijay, Taruna, other candidates, Preeti, Bhumika, Spurti, Sneha, Taruna. Okay, so let's just wait for this to complete. Okay, see, now just look at this. Well, the loss is like decreasing very rapidly. And since the accuracy is not improving so much, but just look at this. Loss is decreasing so much. Okay, you can just increase the like epoch value from 200 to like 500, and then you will probably get the good model as well, right? So from 85%, somehow we have achieved to like, I think 88 or 90%, right? And just look at the loss value, right? From 65% to 24%, okay? And that is the best part of this, right? So you can particularly check your model, and if you want to predict the value, so you know that you have that model.predict method, you can just simply call that model.predict, and inside this predict, you have to pass your test data set. This will give you the y predicted value, and y predicted is like it should be in a form of like numerical values. Let me just show this floating value. Okay, 0 and 1, 0 and 1s, right? But the values that you are getting is not directly in sort of 0 and 1. So what you can do, you have to convert this to 0 and 1 technique using the if else or like list comprehension, or you have some sort of masking technique as well. And that masking technique is called np.where. Where is like you have to just pass the condition. Whenever you are getting the y pred value as less than 0.5, so what you will do, you will simply consider this as 0. And if it is not, you will consider this as 1, right? And let this quickly store this inside the y pred. Okay. And now once you run this, then you will get the final y pred as 0 and 1 format. Okay. And yeah, you are getting the value as 0 and 1. Now you know that you can compare your model with the different accuracy score matrices and all. So let's just simply call this from sklearn sklearn.matrices, and let's just quickly call your classification report and the confusion matrices as well, right? So let's just simply call this, and you can simply call your confusion matrix. You can store this confusion matrix inside the CM, and it generally asks you for the y test and then followed by the y pred. And what you can do, you can just store this inside CM. You use the sns.heatmap. You will pass the CM here, and then followed by the annotation is equals to true. And let's just simply change this SM to CM and quickly write this plt.show, right? So this will show you the values, right? Okay, we are not getting the perfect values, so we have a format technique that is called FMT. Okay, FMT is like the format one, and you can just simply call your formatting is like 0.2G. Let me just check if it's working or not. Yes, it's not working. Let me just go to the documentation part of this. Heat map FMT. Okay. Okay, so it's like 2.2F. Let me just convert this to 0.2F. Yes, it's working, right? So true positive, true negative, false positive, and false negative. These are the values that we are getting. Okay, these are some sort of misclassification. Okay, and if you want to check the misclassification, so you can just simply call this classification report, and inside this classification report, you know that you have to pass the same set of y test and y pred, and with the help of this, you can simply call your y test and y pred, and let's just print the classification report. Okay, now if you want to convert this model into a sort of streamlit model, In the last class, we have already performed this one candidate. Okay, so you can just simply call this one, and you can just simply like transfer your model into the production part of the Streamlit as well. Okay, so now let's just save this model for now. So you can use the plt dot x label and y label as well. Inside the x label, you can give the actual value and the y label predicted value. Okay, so plt dot x label actual churn and plt dot y label, it's like predicted churn. Okay, now just run this. So this is like the actual churn, the model correcting, predicting 201 times perfect and not predicting 172 times imperfect, right? That is the reason we are getting the accuracy of 89 or like 88 set of percentage. Okay, now in this way, candidate, you can particularly create your model. Okay, these are the things that you can generally perform. Now if you want to like visualize this one, keras.history.callbacks, and it is somewhat stored in this like this memory address. So you can just call this one. Okay, now let's just check callbacks.history and .history as well. So you can just go to this. You can plot this, your training and testing part as well. Okay, and how to plot this? You can take a reference of this history dictionary dot object, and you will get the two values. It's like the history dictionary. You will get, okay, let me just first show this, right? Whatever the model you are fitting now, you have to store inside this. But because we have not stored the model inside this one, no? So that is the reason it generally stored inside this memory address, right? So you have to run your model again. You can just particularly wait for a while, and then you can particularly train your model. So let's just do one thing. Okay, let's just finally increase the one more network here, and let's just keep it as 50, and after 50 we'll use the 10 and then followed by 1, and these are the model compilation, model fit, and inside this model fit, let's just use this as a history object. Inside this history object, we want to get the history so that we can predict that value, right? And now if you just run this, okay, just store this. We want to improve the iteration part as well. Okay, just stop this one, create this model, summarize this one, compile this one, and increase some sort of epochs as well, right? Instead of 200, let's just make this as 300. Now just wait for a while, and then you will predict the value. You will convert the values, and then you can probably check the confusion metrics and the classification reports as well. Okay, so let's just wait for a while, and then we have to check the history where we will get the losses and the validation losses, the training losses, and the testing losses you can also get. Okay, you can take a reference of this history. It will give you the overall values of this one, right? Verbos, epochs, like history parameters, these are the things. And if you want to visualize this one now, so you can visualize this one also. Okay, you can take a reference of this notebook, right? So let's just wait for this to complete, and then okay, so we are getting the accuracy of some sort of 89%, and we are like reducing our losses. Perfect. Okay, very good. So now then after that we'll wait for the model to accomplish. Then we can simply check the overall like training loss, testing loss, and accuracy, and so on, right? So you can plot the graph for training loss, testing loss, and the accuracy, training accuracy, and the testing accuracy as well. Okay, you can plot the graph as well. Okay, so we just wait for this to complete. Then we'll check. Okay, so is there any question or doubt, candidate? Once it's done, see, now just look at this now. At just 167 iteration, we are getting the accuracy of 93%, right? So just wait for a while, and then we'll check the overall like plots of all this one, right? Okay, let's just wait for this to complete. Okay, so now what you have to do, because we are already aware with the ANN part implementation. Okay, so in the next class, we'll start with the CNN part, and then followed by the recurrent neural network part. Okay, so I'll give you the introduction for the CNN, and then we'll try to build the model for the CNN as well. CNN is just nothing. It's like the convolutional mathematical process, and then you can particularly do some sort of convolution max pooling. There is a filter approach, and inside that filter approach, you have to figure out the values. Okay, and then you will pass out all the values to the ANN neural network, right? So I'll let you know, right, in the next class. Not right now because the topic is not related to the convolution one. Well, but this one is very easy, right? You will get some input, you will do some filtration part. Okay, this is called the feature extraction, right? You'll try to analyze the pixel, then you will do some max pooling or like the average pooling we have technique. Then you will flatten all the array, and then you will finally connect with the neural network, and that neural network is responsible to predict the value. Okay, so in this way we can simply call out the model, right? Okay, now just look at this. We got the accuracy of 95%. That's good. You can increase the model as well, the hidden layer as well, then you can probably get the more values. But the best part is now, just look at this. The maximum loss was like some sort of 65%, I think. Yeah, it's like 60%. Okay. And we have decreased this loss from 60% to the 10%. And that is the major advantage of training your model. And now we are predicting the values. Now just look at this confusion matrix, right? We have reduced the values so much, right? And you can just check the accuracy and precision score as well, right? Now let's just check the model training part and the testing part. Okay, you can just click on this text. So I'll just try to plot training versus validation loss. Okay, how to do this? Because we have now, this time we have stored our data inside, what was the object? I think it was like history object. Okay, let's just check. We have stored our data inside the history object. Yes, history object. Now I'll call this one. Okay, let me just first show this what exactly this history object is. Okay, this history object. This is the dictionary kind of things. Okay, we are not getting the values. Why? Okay, let me just check. Okay, so inside this history object, now you have to go to the history. Okay, and then write the keys here. Right, we are getting the 4 different keys. Keys are like at each key we have some sort of their training part, accuracy part, validation part, and the validation loss part. Right now, I'll just try to plot the figure to just simply check whether the model, how model trained them, like trained during the training part, right? So you can just call this plt dot plot, and we are just plotting the training and the validation loss. So what is the training loss? This is the training loss, and this is the validation loss. You can just plot the graph between this, right? So just simply call this history object dot history. This is your x data, and inside this you will just simply give your loss. This is like your x data. Okay, and just give a label to this data as like the training part. Okay, copy and paste. This is like your validation loss. This is like your label as a validation loss. Okay, you can just show this graph. You can do the like plt dot x label and the y label as the epochs, and the x is like the number of epochs. You know that you have run the epochs as 300 times, and plt dot y label is like the loss, so you can just check the loss as well. Okay, and if you want to increase the size of this figure, so you can just simply go to plt dot figure and plt dot figure, and just simply give the plt dot fix size. And what you can do, you can just simply try to increase the length and just reduce the width much, right? Now let's just do this as like the color is equals to, this is like the training partner, so it's like the training loss. So let's just write this as a training loss. So let's just keep this as a color as red color, and this one is as a color as blue. Right now let's just run this. So we'll get the some sort of graph like this. Okay, candidate, the figure size is very huge. Let's just change this to 6/3. Perfect. So this is like your 300 epochs, and at this 300 epochs, okay, so we are not getting the label here. Let's just on this legend, right? Then we'll get the label here. Okay, plt dot legend. Yes, this is like the training loss. The we are particularly reducing the loss from 59 to 10%. You know that now. And the validation loss, we are getting some sort of like this one. Okay, now with the help of same graph, you can just simply check your training accuracy and the validation accuracy. So just simply copy this, click on this text, and just say plot training versus validation accuracy. Training versus validation accuracy. And it is somewhat, instead of this, like the loss, now what you can do, you can just simply give the accuracy, and instead of val loss, you can just simply call the val accuracy. We'll get the hint, right? So just simply write this as val accuracy, and then same as it is the training accuracy. And now let's just change the color to, instead of loss, let's just change this to accuracy, and then epochs will remain same. Okay, now everything is perfect. Okay, now just look at this. This is like your training accuracy. Okay, perfect, candidate. So the training accuracy starts with like some sort of 60% now, and we have somehow achieve our training loss, like training accuracy to close to 95%. Okay, so in this way you can validate your model, right? What was the final? It's like the 95%. Okay, so we have plotted our data, and these are very important to understand how model is performing, right? And in this way we can finally predict our model or create our model, right, candidate? So this is all about the artificial neural network. I hope everyone is getting my point. Is there any doubt or like any set of questions? Class, just let me know. Okay, Taruna, Vijay, guys, just let me know. I hope everyone is getting my point, right? Bhumika, Spurti, Preeti. So we have created a model. We have like validated a model. Now you can just take reference of this notebook. You can build your own neural network. You can get the data set. Okay. Now I'll give you some tasks. Pick any like model. Okay. Pick any data set for the regression problem or for the classification one. Okay. Build the model. If the model is like a regression problem, okay. If it is like linear regression, na, so at the output stage, you can just keep it activation function as linear activation function as well, or like ReLU activation function as well. If it is the multi-class classification, so you can call this as like the softmax activation function. Okay, you can call the softmax activation function, then followed by the ReLU activation function inside the hidden layer, right? Now, if it is like the for the multi-class classification, so instead of binary cross entropy, you have to call the sparse categorical cross entropy. So can it, in this way, you can create your model, you can build your model using the deep learning techniques followed by the artificial neural network. And then based on that, you can particularly predict the value. If you want to perform all the things using the streamlit as well, so you can call, like you can build a model using the streamlit as well, right? Okay. So is there any doubt or any sort of issue, candidate? Just let me know, class. Okay. Now we have a one popular model that I'll let you know to perform a practice, and because for that we have to start the convolution one. Okay. So we are still like we have half an hour. Can we start with this CNN one? Just let me know, class. Can we start? Can we start the CNN one, Sneha? Or like Karuna, Vijay, so that you guys can understand the CNN as well, and then you can probably look the how the model is creating using CNN as well. Okay. So now let's just start with the CNN implementation. Okay. Okay, CNN is very easy. If you're aware with the artificial neural network, then you can probably understand the any sort of model, whether it is LSTM, long short-term memory. You can use the like gated recurrent neural network. You can use the RNN recurrent neural network, right? If you're having the NLP task, you can use this one, right? So CNN is not a news channel. It is like the convolutional neural network. So let me just copy this image, and I'll just paste that image here, right? Perfect. Now let's just try to understand what exactly this CNN is. Okay, then you can probably understand. This is very easy, candidate, right? Interview generally asks you the feature extraction part because the rest part is the same as the ANN part, right? So now just look at this. Okay, we have two techniques here. The first technique is called the convolution part. Second technique is called the pooling part, max pooling or average pooling. Okay, now just look at this. We know that whatever data that we generally call inside the any sort of model building or like inside Python, every image is treated as a RGB pixel, right? image store in a form of pixel. Okay. If you are having the black and white image, for black and white image, you'll get the pixel of, see, zero is like absence of color. It's like black. And 255 is like the presence of color. It's like white. Okay. So this is called the black and white image. Now let's just try to understand the colored image. The colored image is short of form of three different channels. The first one is called R channel, second one is called G channel, and third one is called the B channel. Okay, RGB channel, where the each channel has the specific range from 0 to 255. 0 means no red portion, and 255 means 100% red portion. Same followed by the green channel, 0 to 255, and then same followed by the 0 to 255 with the blue channel. Okay, now just look at this. This is very the important thing that you need to understand. What I'll do, I'll just simply go to my file, Google Colab. I'll simply upload some images. Okay, let's just go to desktop and I'll just try to import or call any image, right? Do we have any image right now? Where's the image? Any sort of image? Where is my image, right? Okay. Let's just use this customer one. Well, the image size is very low, so no issue. Let's just call this one, right? Okay. No, it should be like the JPG format. I don't want to call the PNG right now because PNG has some other dimensions, right? So let's just call the Amitabh Bachchan Indian actor, and let's just call one images of that one. And I think this image is perfect, right? Okay, you can call this one also. Okay, now just copy this. You can just open this image. Okay, why the size is low? You can just wait for a while. Just simply click on that particular link. Okay, it's not working. Just simply right click on this. Again, click on open image in new tab. No, it's not working. We are getting the very low quality of image. So let's just simply call this one. Or just do one thing, can it? You can call this one directly, right? Okay. Just wait for a while. Go to this open image in new tab. Yes, it's perfect. You can just simply save this image. It's like Amitabh. Okay. We have that Amitabh image here. Okay. No issue. Let's just save this as to the desktop, right? Now just go to this, call this upload option. You can search for the Amitabh Bachchan image here, right? And now what we want to visualize this image using the matplotlib constraint, right? So first you can just use the path of this, right? So the path of this image is somewhat, path is like, go to this Amitabh JPG, copy this path, and just paste it here, right? This is the path of this Amitabh image, right? Now, if you want to show this image, you have to read this first. So you have this method which is called plt.imread. Inside this imread, you can just simply give the path of this, and you can, if you want to show the like images as well, so you can just read out. Okay. Now we know that if you just give a path of this, it generally store the data inside a form of array. You can just simply check. This Amitabh Bachchan image is not the exactly image. It is like the array format, and array is just nothing, the pixel value of like the given image from 0 to 1. I hope everyone is getting my point, candidate. Is there any doubt related to this one? Okay, no. So whatever the image that you are calling, every image is just a form of array, right? Now let's just try to visualize this array. And we know that if we can visualize this array, so we can visualize the images as well. So let's just call this plt.imshow. Inside this imshow method, you can just call this array and you can just show the image as well. And here you can get the images of this Amitabh Bachchan, right? Now just look at this. This image is just combination of three different channels. Okay, so you can just simply check ARR.shape, and the shape is nothing. It's like we have three different channels. Three value generally represent as RGB, and this is like the length 0 to 200, sort of 240, 2042, and the width is like 1491, right? Now, suppose if you want to slice out those values, right? So you can just play with that, right? So let's just create the another channel. Let's just create another ARR. So it's like uh, Amitabh is equals to ARR dot copy. We are just creating the copy. Why we are creating the copy? Because we want to slice out some values, right? So let's just slice out the values of 0 to see. I want to slice out this face only, right? So let's just slice the value from, I think 200, 150 is enough, right? 150 to 1600, some sort of at x-axis. So let's just call this as Amitabh and 150 to 1600 at x level. And when it comes to y, so y is like you can just check from 180 to, I think 1250 is enough, right? From 180 to 1250. So just call this as 180 to 1250. This is the height, and the channel that you want is called all channel. Now just simply try to show this as I am show, right? You can just show this as images as well, pld.im show, and that is the benefit of using this matplotlib or any sort of this one. So you can simply cut out your like images and you can crop your images as well, and that is the best part of slicing all these values, right? That is the main thing of learning ARR or like any sort of numpy modules and all, right? Because you can play with the data of any sort of images data, audio data, video data, and so on, right? Okay, so in this way we have sliced this data set, right? Now we know that now this channel is like for the three different channel. Now let's just create the ABC of Amitabh. So A is like Amitabh dot copy, okay, and I'll just again create it multiple times. B is like Amitabh dot copy and C is like Amitabh dot copy. I'm creating three different arrays for Amitabh. Why I'm doing this? Because I want to reduce my channel value, right? And we know that inside this A dot shape, we have three different channels. The first is called RGB 0. Okay. So the red is at 0 channel, G is at 1 channel, and B is at 2 channel. Okay. Now just understand one thing. If I just go to this red channel and keep my value as 0, so now we are only having the green and blue channel, and the image will something look like this. So let's just call this A, just go to this all rows, all columns, and just go to this 0 value. 0 is like 0 index of the red channel, and just keep this value as 0. What we are doing, we are just reducing or we are just eliminating the red component from the images. Now just understand one thing. You can play with your images candidate. You can just check pld.im show, and now you are getting the Amitabh Bachchan with just a combination of green and blue. I hope everyone is getting the same, right? Why we are getting, see, is it like we have changed this Amitabh Bachchan color from one sort of to another, right? Do we have applied any sort of color portion here? No, we are just playing with the like arrays, right? And that is the main part of this array calculation and array sort of things, right? So we are just reducing the component of 0. And now if we just change this to 255, now we are just increasing the component of 2 red channel, and you can just check. And it is somewhat like, okay, now this time the red contrast is very high. That is the reason we are getting the Amitabh Bachchan images as like the very reddish kind of something this, okay? So can it, in this way, you can play with the images, right? And that is the reason that deep learning allows you to do all the manipulation over the images as well, right? Because you can do this, right? Now let's just go to B array and just call this RGB or like G channel as 0. And you know that if you just call the G channel as 0, you are having the value of red and green. So you will get the images something like in red and green format. And now just look at this. Red and green becomes pink, right? The combination of red and green becomes pink. What is, let me just go and Google, what is red plus green? What is red plus green? Okay. So the red plus green is some sort of like, it should be like, okay, the red plus green is the yellow color, right? So it's, we are getting some sort of the values like this because we are eliminating the blue channel. And if we are just giving the blue channel as the 255 value, so we will get the, see, RGB. We have used the RGB. Let me just cross verify. We are getting the values as like greenish, na? So it's like R is like the first one. Okay, so 0th is at the R1. Okay, and the 1 we are getting is as like RGB. Okay, my mistake, candidate. This is not for the blue one, right? This is for the green one, na? Because the channel itself say is like G means green. Okay, and the third one is like the blue one. Okay, so you can now understand that is the reason if we are just giving the channel value of 1 is 255. So somewhat we are getting the images look like greenish kind of thing, because we are just like increasing the amount of green color on this, right? Now just understand one thing with the same as C, call all the channels of rows and columns, and then the final values as like the blue channel, and let's just make this as 0. So now we are only getting the combination of red plus green. So what is red plus green? Red plus green is somewhat yellow, na? So let's just check. We'll get the values as like yellowish kind of something, and you will get something like this. Yeah, perfect. That is the reason you are getting the images like this yellowish kind of. See, we are not particularly tempering any sort of images, right? We are just manipulating the things with the help of array calculation and whatever the things that we have, right? Now, if you just try to increase the blue value up to their maximum limit, so you will get the bluish kind of images and the shade like this one. Okay, candidate? I hope everyone is getting my point, right? Vijay, Sneha, Preeti, Bhumika, Spurti, and the rest candidate. Okay. So class, in this way, you can play with the arrays and you can play with the like images portion as well. And when it comes to convolutional neural network, now, so it's very important to understand the pixel behavior, right? It's very important to understand this. Now, what we can do, we have that image, right? So I'll just simply go to my paint. What exactly the convolution is? I'll just simply open with this paint. Okay, just simply open this with paint. And now let's just understand the convolution part. So what is convolution? Okay, first simply copy this. I'll just reduce the size so that you can understand what exactly the convolution is. I'll just reduce the size like this. Okay, let me make this one perfect. Now we are having the images like this. Okay, this one is perfect, right? Okay, so we have this image. Now what we want to understand the pixel value of each images, right? So what I'll do, I'll just simply pick a filter, and that filter we generally refer this filter as a kernel filter. Okay, so you will decide the kernel size. Now let's just give the kernel size as 1 by 1 unit. Okay, so what it will do, it will just try and iterate over the of all images channels. This is like one iteration. Then it will just move 1 unit down, and then it will go backward. It will read out the all pixel value. Then it will go 1 unit down and will read out all the pixel value. Okay, and then we'll go one unit down and then read out all the pixel value, and it will try to keep this thing, and it will try to keep repeating this thing multiple times. Once you completed all the iteration, like from here to here, see, we are moving this now. This is called the kernel filter, and we can decide the kernel filter to just understand the pixel value of each given images, right? And we know that now, if we want to create a model, that model will able to recognize this celebrity face. So the model should generally focus on this area. Na? The coat part, the head part is not that much important. The background part is not that much important, because you know that. Let me just take this one. This image is also can be like, it can be recognized as the Amitabh Bachchan images. So why you are not considering the rest feature? So see, these are the main features, and you have to understand the main feature complexities, right? So with the help of this kernel value in a class, you will particularly try to reiterate all the pixel value. And once you reiterate all the pixel value, then finally you will create a convolution part of this. And what is that convolution part? Convolution part is like doing some operation over that particular pixels value. So you can decide the kernel size. The kernel size now this time is 2 by 2 unit. You can increase the kernel size as 4 by 4. The more you can increase the kernel size, the more feature you will get at one. Okay. So it's important to keep the kernel size as perfect so that you can particularly read out all the pixel value. It will try to move like this way and then try to identify all the pixel value. And we know that now, because the machine learning or like the deep learning generally works on the set of numerical problems. So it will try to understand each values right now. After getting each value, so what it will try, so these are the pixel. Now you are getting each and every pixel, so you will do some convolution process. And what is convolution process in neural network? So it is like a mathematical kind of thing where you are just calculating the dot products, or you are just not the convolutional neural network, convolution in CNN. Okay, it is like a kind of calculation that you're performing. Okay, so let's just take this. This is the input image that we have. Okay, the input image is like by the pixel, and you are applying a sort of filter. And after if you are applying the sort of filter, so you are doing some sort of calculation. It's like the array matrix multiplication. Okay, 9 multiply 0 plus 4 multiply 2 element wise operation plus 1 multiply 1, 1 multiply 4 plus 1 multiply 4 plus 1 multiply 1 plus 1 multiply 0, and you are doing some sort of calculation, and then you are summing up all the value, and you will get the final values as the 16. This operation is called the convolution operation. I hope everyone is getting my point, candidate. Interviewer will ask you this question, right? What do you understand by the convolution one? Okay, so what is convolution one? You will give some input images, you will decide some sort of filter value. The filter value, see, we have the input images, we have the fixed pixel array values, right? But how to decide those pixel, those filter value? Those filter values are decided by the models, and that is the reason that we have to change that filter value. If we are not getting the perfect result, we will change that filter value, and that filter value is somewhat similar to the weight of that particular model, right? Once you got the filter value, it is randomly initialized between 0, 1 and 2, right? Once you got the filter value, then you will try to do the element wise dot product or like multiplication operation here, and you will summing up all the values, then you will get the final value. And this iteration is called the convolution part. Okay, and you have to repeat this step. If you have to repeat this step multiple times during each iteration. See, if the kernel size is this, so you will do that step, and then you will move 1 unit, then you will again repeat that step, then you will move 1 unit, then you will again repeat that step and move 1 unit, right? So these are the steps that you have to perform, candidate, and this is called the convolution part. And you have to perform this step multiple part, unless or until if you have not completed the all scanning of the images, right? So this is the input image. You will decide the filter, you will create a set of arrays or like the finally filter value, and you will do some matrix calculation, and that matrix calculation is called the convolution part. Now you know that if you get the convolution value, now you still get like very huge values. So you have to keep summarize this value. How you can keep suppress and summarize this value? There it will come. That is called the pooling part. Now let's just again take this. What is the convolution part? The convolution part is like getting the input value, applying some sort of kernel filter, do some matrix multiplication element wise, and then summing up all the value, and you will get the final kernel output value, which is called the convolution value. Once you get the convolution value, candidate like this one, then you will again try to reduce the size of this array. And how you can do this? And another technique is called the max pooling technique. Okay, with the help of this max pooling, suppose this is the final array that you got, right? Okay, let me just call this max pooling GIF, right? Then you can probably understand. Okay, suppose this is the final output that we'll get, and what exactly it will try to do? It will try to find the maximum value of, let's just use this one, right? It will try to find the maximum value of the given output value. See, this is the kernel filter value 2 by 2, right? Now just look at this 2 by 2. What is the maximum value of this 2 by 2 array? Is it 0, 3, 2, or 7? So the maximum value of this 2 by 2 array is like 7. So you will just pick that 7 value and keep it here. And again, you will repeat the same step with this array. What is the maximum value of this array? It's like 3. You will pick that value and keep it here. Then again, you will do the same step with this one. Now, what about this one? This is not the input image, candidate. This is the convolute image. And how to get this convolute? You will get the input image. You will convert this image into 0 and 1 pixel, or like within between 0 and 1. Then you will apply some kernel filter approach, which is called the convolution part. And once you get the convolution output result, then you will use this max pooling technique. And inside this max pooling technique, you will try to again fit a kernel size by 2 by 2, and each 2 by 2 kernel size will go to 2 by 2 array and try to pick out the maximum value. That is called the maximum pooling. And that is the reason we are considering this as a maximum pooling. We have another pooling method also, that is called the average pooling. Inside this average pooling, you are not just simply finding the maximum. You just simply call the average of this value. It's like 0 plus 3 plus 2 plus 7. So it's like 7, 3, 10 and 2. It's like 12. And if you just divide this 12 by, because you have the 4 arrays now, so 12 by 4 is like 3, so you will get the final output as 3, right? And you will again give the average pooling as here, you will get some output here, same as it is from this and from this. And this is called the pooling part, candidate. Okay. And in this way, you have to repeat this step again and again so that you can get the maximum features. So you will get the image, you will do the convolution part. What is the convolution part? You will perform this step, right? Once you perform this step, the second step is called the pooling part, and this is called the feature extraction part 1. Now you can create this. See, this is again a dense part, right? You can create this again. You can again call the convolution part and then pooling part. You can again call convolution part and then pooling part. You can again call convolution part and the pooling part. Okay. Now once you call all convolution part and the pooling part, and if you are satisfied with the feature extraction, then at the final output, whatever the array that you will get, you will flatten that array. It means the n-dimensional array will be flattened to the 1D array. And once the array flattened to the ND array, now it will work like this. The ND array will behave like the input layer for this artificial neural network. Now, once you got the flatten array now, then you will finally convert the flatten array into the ANN network. And you are already familiar with the ANN network. Then it will try to just retrain the model, adjust the weight, and finally give you the output. So what is CNN? CNN is like the convolutional neural network, where you will get the feature from the convolution part, and convolution is like the matrix multiplication part. You will decide the kernel filter, it will calculate the value using the dot product or like the multiplication part. Once you get the value, then you will perform some sort of pooling technique. Inside the pooling technique, you have max pooling or like the average pooling. Then once you perform the average pooling or like the max pooling, you can repeat this multiple times. You have to flatten your layer, then followed by the ANN part, and then probably you can create this convolutional model. Okay, this is called the convolution part, and you can give this convolution part and the pooling part multiple times. Now just look at this image, right? So this is the image. We are just we are performing the convolution part, then we are getting some sort of max pooling data here. Again, we are performing the convolution part. Again, we will get the max pooling data here. If you want, you can again perform the convolution part, then again you can get the max pooling. And after that, you have to flatten your array. Once you flatten your array, you can create the neural network, and that is called the ANN part. That is called the feature extraction part. And finally, it completed into one that is called the convolutional neural part. So convolutional neural network is nothing, just a feature extraction part, which is done by the convolution and the max pooling or like the average pooling technique. And second is like the ANN part. And once you connect both feature extraction and the ANN part, it finally becomes the convolutional neural network. So candidate, let's just keep this for today, right? In this way, we have completely understand what exactly this convolution part and the max pooling part inside the CNN model. Okay. So in the next class, we will try to develop a model from the scratch for the CNN part as well. Okay. Then we will understand what is the use of the kernel part and the all rest details, right? So I think everything is perfect for today. So we have completed a 2 hours of session, right? Back to back. And let's just connect tomorrow. And we'll start with the practical implementation of the CNN. It's very easy. You can decide the dense neural network followed by convolution and the kernel padding, max pooling, and then you have to create the dense neural network, and then you can retrain your model again and again, right? So is there any doubt or question, right? If you have doubts or question, you can just refer to the notebook. The notebook is already shared with all of you guys, right? So you can just take a reference of the class videos as well. And now let's just connect tomorrow. Okay. Bye-bye.